In this video lesson, we are going to explore how to algebraically manipulate mathematic formulas, mathematic equations, so that you can rearrange an equation to solve it for the variable you are trying to solve for. So we start by looking at the equation A over B equals C over D, and we are meant to solve this equation for D, which is a little problematic because D is in the denominator. So to keep in mind what this means to rearrange a math equation so that it is solved for the specific variable D, is that the first thing we have to do is we have to get D into the numerator, because solving it in the denominator is not solving for D, it's solving for 1 over D. And it's conventionally easier to understand if D is on the left side of the equal sign. It doesn't have to be, but it does. Most people prefer to see it this way. So we want to put D on the left side of the equal sign. And we want to get D all by itself. We don't want A or B or C to be on the left side of the equation. So strategies to rearrange an equation, neither one is better, it's just a matter of which one works better for you. And that is the balance strategy, which is whatever you do to one side of the equation, you must do to the other side. So for example, since D is in the numerator, the first thing we want to do is put it into the numerator. And so if you flip this equation, right, but putting D on the top and C on the bottom, we would also have to do it to the other side to main proportionality. So if we did B over A equals D over C, we've accomplished the first task of putting D into the numerator. And then of course, if we flip both, if we flip the equation so that D over C is on the left side and B over A is on the right side, and then what we see here is that D is not all by itself. It's currently being divided by C, right? So if I multiply this fraction by C, well, if I do that to the left side, I'm going to have to do that to the right side. And then, of course, simplify, right? So C over C is going to cancel, leaving us with D on the left, and then we're going to have BC over A. Right, so that's one way to approach this is whatever you do to one side of the equation, you have to do to the other. Or if you're familiar and comfortable with cross multiplying, that's where you take the numerator from one side and the denominator from other, and you multiply those. So you get A times D. Then you set up your equal sign, and then you're going to multiply B times C. Right, and so automatically what that does is it eliminates all variables from being in the denominator. We want to get D all by itself, however, and so we're going to divide both sides of this equation by A. And when we simplify, we see D equals BC over A. So we get to the same result either way. There's just different ways of manipulating those equations. Well, let's take a look and see how this looks with some other kinds of just kind of practicing, right? I will be demonstrating here the cross multiplication method. So for number 1, n over 385 equals 6 over 7. So here we're going to get 7 times n equals 385 times 6, right? And then in my calculator, I have 385 times 6 is 2310. So 7n equals 2310. Divide both sides by 7. And we're going to get n equals 330. Okay, so that was, I'm going to do this equals n, just to kind of satisfy that we got to a final answer. All right, now we can also see that it works even when the variable is in the denominator, right? So this becomes 392 times h, right? We're cross multiplying those two. And then we're going to set up an equal sign, and then it's 300 times 98. 300 times 98 gives us 29,400. right? Dividing both sides by 392. By 392, we're going to get h is equal to 75. Okay. All right, so those are, fairly straightforward examples of what you would have seen in a math class in some previous course. Now, here we have in questions 3 and 4, we have some things that we make no sense to us coming in, but the idea here is that we can still use this skill even when there's no numbers to manipulate. So if we're solving for apples, I'm going to circle the variable that we're trying to solve for, just to kind of keep us eye on the goal. But this would just be apples times bananas equals grapes times oranges, right? And so we want to get apples all by itself, so we have to divide both of these by bananas, right? And so simplifying, we get apples are equal to grapes times oranges over bananas. And that's the answer. Okay, there's no math there, just manipulating the equation. Same thing for solving for this variable, cross-multiplying. I'm going to start with this symbol times this symbol equals this times this. Right, and so we're assuming that you know that when we put two of these variables together without any symbol between, that implies that it's multiplication. But since we are trying to solve for this symbol right here, we're going to divide both sides by the circle with the dot. And simplifying this for our final answer, we get circle with a plus sign, circle with a diagonal line, all over circle with a dot. Okay, so it's important to show the simplified answer to really clearly articulate our answer. Solving for A, again, cross multiplication. I have A times D equals B times C. I'm still trying to solve for A, but I have D in the way, so I'm going to divide both sides by D, and I'm going to get an answer of A equals BC over D. This time we're trying to solve for B. Cross multiplying, A times D equals B times C. I'm solving for B, so I'm going to divide both sides by C. And then I'm going to rearrange it so that B is on the left side, so B is equal to AD over C, kind of simplifying and cleaning it up. And now we see an equation that's a little bit more complex. P1 V1 over T1 equals P2 V2 over T2. In this case, we're solving for P2, right? I'm still going to cross multiply. So cross multiplying, I see I'm going to start with P1 times V1 times T2 equals T1 times P2 times V2. Now I'm going to circle P2 again to remind ourselves that that's what we're trying to solve for, which means I have to divide both sides by T1 and V2. T1 and V2. So T1 and V2 cancels, and I'm going to clean this up to say that P2 is equal to P1 V1 T2 over T1 V2. In our last example here, we're solving for T2. This is problematic because it's in the denominator, but when we cross multiply, we get rid of all denominator variables, which is helpful. So we start by P1 times V1 times T2 is equal to T1 times P2 times V2. I'm going to circle what I'm solving for, recognizing that I need to get rid of the P1 V1, so I'm going to divide both sides of the equation by P1 and V1. Cleaning it up, I have T2 is equal to T1 P2 V2 over P1 V1. All right, so now let's put this into practice. We're going to use a very simple equation that I assume you have knowledge of how to use it from a previous year, and that is density. But we're going to use this to focus on the skills of manipulating equations and solving simple problems, but following these best practices of how to manipulate equations. So let's start by understanding density, what it is. It is a ratio of an object's mass compared to its volume. So mathematically, density equals the mass over the volume. Sometimes we can just say D equals M over V for simplicity's sake. Units for mass are usually grams, abbreviated as a little g. Volume can be written either as milliliters or cubic centimeters. So that means that the density unit is either grams per milliliters or grams per cubic centimeters. Or it could also be grams per liters, but the idea is it has to be a mass unit divided by a volume unit. So in this unit, as I said, the focus is on algebraic skills first. The answer is secondary. So on that note, we're gonna talk about what are called best practices to solve math problems in chemistry. Right, and so I really want to see how you articulate the work that you're doing. The answer itself is important, but much less important than you being able to communicate the logic behind your problem-solving abilities and communicating that process. So the first thing I'm going to ask you to do when solving problems is to write the equation rearranged for the correct variable, which is why we just spent the last few minutes working through some practice problems there. You'll then substitute the given values, including any units that went with those values, and then you will round your answer appropriately and include the correct unit. Now, how to round your answer, we're going to, if we haven't yet covered that in class, that will be covered in units 7.1 and 7.2, that there are some guiding principles on how to know how to round your calculated answers. Right, so rounding your answer, when we cover the information in 7.1 and 7.2, we will address that more thoroughly. But for right now, the idea is that you have to round your answer to something that makes sense. So first example is, what is the density of a material that has a mass of 45.82 grams and it takes up a volume of 8.75 milliliters? Okay, so what is the density? We are trying to solve for density, which is D. It has a mass of 45.82, that's going to be our mass, and our volume is 8.75 milliliters. So the equation that we're using is density equals mass over volume, right? Nothing to rearrange here because this equation is already solved for density. So substituting in, we would say D is equal to the mass of 45.82 grams. So I'm substituting the full number and the unit. And then I'm going to divide that by the volume, which is 8.75 milliliters, right? Calculator work is 45.82 divided by 8.75, and we get this crazy number in the calculator. We're going to round this to have 2 digits after the decimal, so we're going to say that the density is equal to 5.24 grams per milliliter. Okay, so these are the steps: showing your rearranged equation, showing the substitutions, showing the final answer rounded with units. Second problem, the density of copper is 8.96 grams per cubic centimeter. That's our density. What would the mass be of a sample that has a volume of 32.6 cubic centimeters? So the mass is what we are trying to find. So if we start with the density equals mass over volume equation, we need to solve this for mass, right? And so recognizing that this is really just D over 1 equals M over V, and then we cross multiply, we're going to get D times V is equal to M, right? So flipping that around, the mass is equal to the density times the volume. So either one of those is satisfactory. I like to use this one right here. Somehow reading left to right, it seems to work better for for chronologic solving of the problem, okay? But this one also is okay for sure. So we're solving for the mass, and now we're going to substitute in our density, which is 8.96 grams per cubic centimeter. And we're going to multiply that by 32.6 cubic centimeters. Right? Now I'm going to show here that cubic centimeters here is in the numerator, cubic centimeters here is in the denominator of this unit, so any unit over itself is equal to 1 and cancels out. So our final answer is just the product of 8.96 times 32.6. We get this number 292.096. We're going to round it to the nearest whole number here, 292, and the unit that did not cancel is grams, which makes sense because it's supposed to be mass. Our third example here is what volume of acetone, so volume is our unknown, what they're asking for, would have a mass of 142.5 grams and the density of 0.784 grams per milliliter. So starting with density equals mass over volume, and we're trying to solve for volume. Remembering that this equation is d over 1, we can cross multiply. D times V equals M, but since we're trying to solve for V, we're going to divide both of these sides by D, and so we have volume equals mass over density. This is the rearranged equation for volume. So now we can go ahead and substitute. Volume equals 142.5 grams over a density of 0.784 grams over milliliters. Now we're going to notice that grams over grams cancels, leaving us with a unit of 1 over milliliters in the denominator. And when you are dividing by a unit that's basically an inverse of itself, this ends up algebraically manipulating to the final unit of just being milliliters. Milliliters ends up being the unit in the numerator. So that's super convenient and helpful. It's basically the only unit that doesn't cancel. So, and it's a unit of volume, so that perfectly makes sense. So now we're going to do the calculator work. 142.5 divide by 0.784. And we get this crazy number. We're going to round this to the nearest whole number here, where we have a volume of 182 milliliters. Okay, so the idea here is, yes, this is great. You've got an answer, but the skills of, rearranging your equation first, then substituting the numbers in with units, and then recording your final answer rounded with units. Those are the skills that we're going to be looking for you to sharpen in this unit. I have no doubt that you can do this math. It's more about communicating the skills. So with that being said, we'll see you back in the classroom to try some problems independently.